Hello, Dean KK4DAS here. Welcome to the SolderSmoke Challenge Direct Conversion Receiver Audio Amplifier stage. You've made it this far. You're about to build the final board, after which you will have a complete direct conversion receiver. And so let's jump in and talk about the audio amplifier. You'll recall we have 4 boards, and the last of the boards is the audio amplifier. This is a 3-stage transistor amplifier. It amplifies the audio signals and drives an 8-ohm speaker. Now this is the only gain stage in the receiver, so we don't have any amplification prior to this, and it needs to produce about 80 to 100 dB of gain to take those very weak RF signals and amplify them into a level that can be heard through your speaker. And so 80 to 100 dB of gain, and that makes the layout and design of this circuit critical, because if you'll recall, when we talked about the oscillator circuit, we talked about how an oscillator is simply an amplifier with feedback. So a little bit of the output gets back to the input, and like a cat chasing its tail, it starts to amplify, or like a loudspeaker in a PA system. If you get too close to the microphone with the speaker, or it's too loud, it will take off and start oscillating. We do not want our audio amplifier to oscillate. We want the audio amplifier to amplify and put out a nice clean signal. So construction of that stage is going to be important, because this stage tends to oscillate. So let's take a look at the design, and then we'll walk through the schematic. Now, we call this the audio amplifier stage, and it is on one board, but it's actually 3 stages. There are 3 independent common emitter Class A amplifiers in the circuit, and they're all essentially identical. There's a minor difference that I'll explain in a minute in the last stage. We use NPN transistors, as we're using a 2N3904, which is the same transistor we used in the PTO. The very common circuit for the common emitter amplifier is right there on the right. You will see this circuit over and over and over again in radio designs. It's used in the audio stages. It's used in the RF amplification stages. It's a very, very common circuit, and it's one that you should get to know. I'll talk a little bit about the components and what they do, but for a much more detailed description and again a deeper understanding of how these transistors work and how these amplifiers work, highly recommend, as always, Alan Wolke W2AEW's videos on the topic. And in particular, in this case, video number 273 gives a great description of how a common emitter amplifier is built and why the values are where they are. So C1 and C2, those are just blocking capacitors. They block any DC coming in or out of the circuit and pass AC, in this case audio AC. And if you think about it, we want each stage to operate independently of the other stages as much as possible. So we want to keep extraneous DC out of our circuit, and we don't want to send extraneous DC down to the next stage of the circuit. So that's what those are there for. R1 and R2 form a voltage divider that sets the voltage at the base of the transistor. This is known as the operating point, or the bias of the transistor. Simple voltage divider, and you can calculate what that voltage is going to be by using the voltage divider formula applied to the input voltage. RL is the load resistor that essentially sets the load current. That's going to be the output current of the transistor. And RE is the emitter resistor, and that sets the emitter current. C3 is known as a bypass capacitor, and what that does is it bypasses AC so that the emitter resistor RE only affects the DC operating characteristics. And the values of those components are what makes the amplifier operate at the level that it does in the frequency range that it does. So we have 3 stages of common emitter amplifier in the audio board of our receiver. So let's take a look at the full schematic, and we'll kind of walk through that, and then we'll get on to building it. So this is the schematic for this three-stage audio amplifier, and you can see we have three transistors, Q5, Q3, and Q4. From left to right, we have the audio input, which is coming from the diode ring mixer. So we've got that 33 microfarad cap, which again is blocking any DC and allowing audio to flow into the transistor. You'll notice that the bias transistors, in particular R8, R12, and R16, have this funny value of 14.7K. Well, that just comes from the design equations for the amplifier. We use the nearest common value, which is 15K in our circuit. So R16 and R17, starting with Q5, again set the operating point bias of Q5. R18 sets the load current. R19 is the emitter resistor, and C13 is the bypass capacitor. And if you look at Q3, you'll see it's an identical stage. And if you look at Q4, you'll see it's identical, except for the fact that the load current is actually set, instead of by a resistor, it's actually set by the primary of the output transformer. All right, a couple other things to look at here. In the middle, after Q5, you see the 10K audio taper. That's the audio volume control. That's an audio potentiometer. An audio taper just means that it is designed to work well as an audio control, because it'll give you fairly even amplification as you turn it from left to right. A linear taper will provide more. It'll provide a greater or faster transition in the audio output as you turn the dial, and it won't feel as natural or comfortable. R20 is an interesting component here in this circuit. We found in some builds of the circuit that if you have a fairly hot Q5, in other words, it has a high HFE, that you will introduce distortion into the following stages of the audio amplifier. So R20 is an optional resistor that is put in to knock down the signal coming out of Q5, to make sure that we have a cleaner signal across the following stages. You may need a smaller or larger value. We found that a 220 worked well in the cases where we had it. In some cases, we don't have that transistor in the circuit at all. So that's something that you'll have to look at as you tune up the audio circuit. Let's see. Another thing to think about is the audio transformer at the far right. So that's L4 and L3. L4 is the primary coil, and L3 is the secondary coil of the audio transformer. The ones that we're using, the ones from Mauser, have a P printed on the side of the primary, so you know which side is the primary and which side is the secondary. If you don't have that printed on your particular transformer, and you don't know which side is which, just use a regular ohm meter and check the DC resistance across one side and then across the other side. The side that has a higher DC resistance, say around 50 or 60 ohms, will be the primary, and the one that has a lower one, maybe around 1 ohm, will be the secondary, which goes to the speaker. Now, those are DC resistances. Those are not the AC impedances that you would expect. So we still want an 8 ohm speaker at the output. Couple of construction hints. Again, there is a high tendency of one or more of these stages to oscillate and produce oscillation, particularly as you turn the volume up. So a couple of hints: keep all the leads as short as possible. Don't have your your capacitors and resistors standing up like giant towers. Have them short. Make sure the grounds are good. I like to use a single DC bus bar rather than running wires from stage to stage. Everywhere there's a wire, you basically have an antenna that can pick up audio and RF and introduce noise into the circuit. In general, keep your outputs away from the inputs of each stage. So I know it seems a little silly when you're talking about an inch, but it can make a difference. So if you build the circuit from left to right, kind of in the way you see it here, you will have effectively kept the inputs of each stage away from the outputs, and you shouldn't have too much trouble there. The one place where you got a wire kind of pulling out of the board is the volume control. So if you can use shielded wire, that would be great for the audio pot, or twisted wire. You'll see that I actually braid the wire to get the twists in there, but you want to have some way of shielding that wire so that it is not producing excess audio or extraneous audio or noise into your circuit. So those are the key points in building the circuit. It's not a difficult circuit to understand when you break it down into the stages, but it is important that you pay attention and use due care when you are building the circuit. Let's see. Last thing I would say is, because it's 3 stages, is we want to build this in stages. And I'm going to recommend that you start with the Q4 stage. You start with the output stage and the speaker, because you can test that and then you'll know that it's working. Then back up and build Q3, then put in the audio taper, then build Q5 to finish it up. And that's the way I'm going to build it, as you'll see in the demonstration. So that's it for the intro. Let's dive in and build the audio amplifier. So let's build the audio amplifier. The audio amplifier may be the most complex board in our radio. It's the 4th of the 4 boards, and after that is built and tested and hooked up, we will have a complete direct conversion receiver. So the audio amplifier, as we've just seen, consists of 3 amplification stages. Each is a 2N3904 transistor and all the varying resistors to set the voltages around them, capacitors to interconnect the stages, volume taper, audio taper, potentiometer as the volume control. That's a 10K audio taper, despite what the earlier schematic said as 1K. And then all of the pieces required to make the provide the DC voltage and to block RF off the DC line. So this is a complex board with 3 different stages. And of the components, the one that is likely to give you trouble, possibly going to give you trouble, is the transformer, because it has to go in the right way. Now, if you happens to buy the transformers from Mauser that were suggested, they have a black P on one side of them. That's the primary side. That's the side that goes towards the transistor, and then the other side goes towards the speaker. But if you don't have that and you have trouble figuring out which one is the primary, just measure the end 2 pins on each side, and the primary side is going to have a measure it with your ohm meter, and the primary side is going to have a resistance somewhere around 56 ohms, and the speaker side will have a resistance of somewhere around 1 ohm. Now those are DC resistances, so they're not going to match the 8 ohms and the 1K that you expect, but that'll give you an indication of which side goes to the transistor and which side goes to the speaker. For these that have 3 leads, we're not going to use the center lead, so I'm just going to bend those up out of the way so we don't get confused. And that's how we're going to put the transformer in. Now, we're going to start this particular board at the speaker. So we're going to put the speaker, the audio transformer, and the final stage of audio amplification together, and then we're going to test it. And we should be able to tell that we're getting noise out of the speaker once that first stage is built. Once that's built, we'll work backwards. We'll build the Q3 stage, then we'll put in the volume control, then we'll build the final stage, which is the input to the audio amplifier. So we're going to actually build this backwards, because when we hook this up, we can test each stage as we go and make sure that it's working. So once again, we're going to build in stages, and we're going to make sure that each stage is working before we go to the next stage. The first thing I'm going to do is put together our DC power rail. And that DC power rail is, I've just cut a long piece of PCB board that I'm just going to put on right there, and that'll be our 9-volt PCB. If you don't do that, you can use individual pads and just jumper them together, but for convenience, I'm going to use one long piece, and that'll be our 9-volt rail. I'm going to put it down a little bit on the board just in terms of construction technique, because I'm going to put the bypass capacitors to ground on this side just to keep them physically away from the rest of the circuit, so that I can have enough room to build the rest of the circuit. So that looks like we're going to bring in our 9 volts, and we're going to have two 47 microhenry caps on there, and those are just to bypass any RF, any audio that happens to be hanging on the 9-volt line, so that it doesn't get into our circuit. So that's what those are. Those are bypass caps that are going to bypass any audio frequencies to ground. So we don't want any audio coming in over the DC power rail. I started by doing a little bit of layout planning for the board. So I have the power rail here. I have the input pad here, which is going to go to the mixer. It's going to go right to the cap that's coming out of the mixer. And then I kind of laid out where I want the audio transformer to go. I kind of bent the leads so that one of them is going to go to the power rail. This other lead is going to go to the collector of Q4, and then the output side is going to go to this me pad right here. So that's going to allow me to get the audio transformer on the board, and then I'm going to have 1, 2, 3 stages of amplification in there. So now I'm ready to put the transformer on the board, build the Q4 stage of the audio amplifier, and test it. So I'm going to put the audio amplifier on the board. I'll put the Q4 stage on. I'm also going to put these 47 microfarad audio bypass caps on there. So those are intended to bypass the audio. Any audio that happens to be on this 12-volt line is going to get bypassed to ground by those, and so it will keep noise out of the audio circuit. So I'm going to put those together now. So the audio transformer is in place. I also have one of the bypass capacitors in place, and I put the pads down for the transistor. So that'll be the collector, the emitter, and the base of the transistor. So now I'm going to solder in transistor Q4 and all of the resistors and caps to make that amplifier happen, and then we will take a look at it and give it a test. So the Q4 stage of the audio amplifier is built. I included the C8 capacitor, the 10 microfarad capacitor, that is the coupling capacitor, so that I could feed a signal in and see what it sounds like. Now, when you hook up a speaker to an amplifier like this, it should make a little bit of noise when you connect the power, and possibly when you touch the input. Certainly when we have more amplification stages, it will make a lot of noise. Now, you may or may not be able to hear it, but when I hook it up, there's going to be a little bit of a static. Let's see. So I don't know if you can hear that, but that's what happens. And then sometimes you can even get a little more static just by touching the input. Now, I'm not really hearing anything there. But I have my signal generator set up, and I put a 700 hertz tone in at 120 millivolts. So I'm just going to hook up that, and we should get some audio out. So there we go. There's our there is our first stage of our amplifier working. Let me turn the amplitude down a little bit here. I think I was overdriving it a bit. But there we go. So the first stage of the amplifier is working, and I like to test each stage as I go so that I know that when I hook the next stage up, it's also working. So the next thing to do is to build the Q3 stage and the volume pot. In keeping with the idea of building in stages, I'm now going to build Q3 stage, the middle stage of the audio amplifier, and that picks up from C8 all the way over to C14, and then we'll add the potentiometer later. Now, one thing I like to do, or I like to point out with Manhattan-style construction, is you can often build the board exactly like you see it on the schematic. You can just follow base, collector, emitter. And so I put down 3 pads for the transistor, base, collector, emitter, and that's generally how I start when I'm working with transistor circuits. So it makes it very easy to kind of translate from what you see on the schematic to what you see on the board. We have completed the Q3 build, so the next transistor is in. And now that we have 2 stages in there, I think we'll find that when we touch the input, we're going to get a nice little noise on the speaker. There it is. So the 2 stages are in and amplifying. And we got a nice loud hiss, so we've got 2 stages of amplification in. Next step is going to be to put in the potentiometer, and then we will see from there. Now that the second stage, middle stage of the audio amplifier is in and tested, it's time to put the potentiometer in. Now the potentiometer is a 3-terminal device. It has the center terminal is called the wiper, and that's going to go to this input side of this C14 that we just used as the input to Q3. The top of the potentiometer is going to go to this C12, the negative side of C12. This resistor, the 220 ohm resistor, is optional. We put it in there because sometimes there's too much gain coming out of this stage and it causes distortion, and this knocks down the first stage a little bit. So don't put that in until after you get a chance to test. When you look at the potentiometer, the center terminal is the wiper, and then I'm going to use this yellow wire to be the high side and the blue to be ground. The reason that they're braided is we want to keep noise off of these wires, and it's just like having a twisted pair. You can use other techniques to get to keep the noise off of the audio line. You could use shielded wire. You could twist the top 2 wires together and have a twisted pair and just run the ground to ground. But in any case, I do this just to keep the noise off of the wire. Many ways to deal with it. All right, I've wired in the potentiometer. Now I want to show you something before I proceed. As I mentioned before, the middle wire, the green wire, is the wiper, and that goes to the input side of C14. And the high side, which goes to the output side of C12, is actually the blue wire. It's the one on the left, and then the yellow is the one that goes to ground. Now, depending on which one of those you choose, that's going to determine whether the volume pot turns clockwise or counterclockwise to increase or decrease the volume. If you happen to get it backwards, you can just swap them and it will work just fine. So, got the battery hooked up. Let me see if I can get a little bit of noise in the circuit. Whoops. Volume down, volume up, volume down, volume up. All right, so the pot is in there, and now it's time to hook up the input transistor Q5, and then we will have a working audio amplifier. The audio amplifier is complete. Now is the time for the last kind of bench test before I hook it up into the receiver. I've got the tiny SA set up as a signal generator, generating a 1 kilohertz signal at minus 63 dBm. And I've put a temporary cap on the input, so I have a way to couple the signal into the audio amplifier. And now I'll turn on the signal generator. And there it is. Okay, it's very hot, that's why it kind of starts to buzz. But the audio amplifier is working. Now what I don't know is if when I put it all in the circuit, if it's going to oscillate or if I'm going to have issues like that. Now I only have one of the DC bypass caps on. In fact, this is the other one here. I borrowed it for that temporary circuit. I may need to add another bypass cap. And then I've got that 220 ohm resistor that we talked about that was R20 on the schematic, which I may need to put in to knock down the input from this transistor, but I'll see what happens after I get it hooked up into the receiver and start listening to it. So I've just turned on the direct conversion receiver. This is SolderSmoke Challenge. I guess I'm going to call this SolderSmoke Challenge serial number 001. This is the first on-air test. So I've temporarily hooked it up to a dipole antenna out in the back, and people have noted that these things are a little bit tricky to tune. So I'm going to show you kind of how you tune in a single sideband. You kind of got to creep up on it. And then you kind of rock back and forth. So you just kind of creep up on it, rock it back and forth until it sounds good. And I've done no adjusting of the coil. I've added none of the enhancements that I've talked about to make tuning smoother. One of the things that you'll notice right off, though, is that when I get the volume up too high, it distorts and goes into oscillation. So I have a little more work to do on the audio chain, and I will do that. So that's what sideband sounds like. Let's tune down the band now and see what it sounds like down in the digital and CW portion of the band. There's the FT8 signals. Let's tune down a little lower. So there we have it. We have completed building our direct conversion receiver. Just 4 boards, from the oscillator to the mixer to the bandpass filter and now the audio amplifier. But we're not done. We still have to do a little bit of work to clean up the circuit maybe a bit, maybe improve the audio a little bit. We need to get it mounted so that the controls are mounted better. Hook up an antenna connector. There's a few things that we still want to do, and I'll go into those next week as well as talk about possible other things that we might want to do to the circuit. But we've demonstrated that with 4 simple boards, you can build a very effective and nice sounding direct conversion receiver. One thing I would advise you is to listen at various times of the day over a couple of days before you start making any changes to the receiver. Even fussing with the audio stage, just listen. Listen in the morning, listen during the day, listen during the evening. 40 meters is a very finicky band, and sometimes the signals are very strong, and sometimes they're not so strong. And sometimes you think you need more amplification, and sometimes you think you need an RF attenuator. So listen before you make any changes, and it's one of the best pieces of advice I can give you. Our friend Pete, N6QW, is fond of saying when you finish a homebrew radio build that you wonder that it works at all, and then you begin wondering how to make it work the way you want it to. And so that's the stage we're often at. It often takes a little bit of tinkering to get a receiver working exactly how we want, even once we've built it, even if we follow the directions exactly. There's enough variability in the components and in the construction techniques that things often don't work perfectly the very first time you hook them up. You have to do a little bit of tinkering, and that's part of the joy of home brewing for me. It makes it fun as we tune it up and we learn along the way. So thanks to everybody who's been building this receiver. Like I said, we're not done. I'll be back with another video with some updates and changes, and I have a few more videos in mind that just talk about antennas and tuning and noise on the bands and that sort of thing. But for now, congratulations on your build of the SolderSmoke Challenge, and thanks for sticking with us. This is KK4DAS saying 7-3 for now.